Okay guys, so this is the Algebra 2. This is the second version of the review for the year. And so we're going to be going through this version. The other version we'll go through in class, so just kind of keep that in mind. Here in this second version, first question, we need to graph this. We also need to state the domain. The domain restrictions come from the denominator and what makes the denominator 0. If I factor x squared plus x plus or minus 6, it'd be x and x. I can split the 6 so that it minuses to 1. That'd be a 1x. That'd be 2 and 3. Okay, and because the 6 is negative here, I'm going to have one of each sign. Because I have a positive in the middle, that means my bigger sign has got to be positive. And so I end up with this. On top, we still have the x minus 4. So the reason that matters is my domain is a list of the things that the denominator can't be, and I can't let the denominator be 0, so x could not equal 2, could not equal negative 3. So I'm going to go ahead and do a bad job of drawing my two lines, my x and y axis, there and there. Okay, so I should have a vertical asymptote at positive 2, which would be right here, and a vertical asymptote at negative 3. That's my domain restrictions, things I can't use for x. The next thing I want to look for, so that would be my VA is 2 and negative 3. My horizontal asymptote, because this is bigger on bottom, it's x squared on bottom, but just x on top. It makes it bottom heavy, which means that it'll be at 0 is where my horizontal asymptote is going to be, so that's right through the center here. And then one last thing that's worth looking for, if you can find it, would just be trying to figure out if you know what makes the top equal to 0. The top is going to be 0 when x is 4. So over here at 4, I should actually be touching the x-axis there. Otherwise, I'm actually going to use my calculator to help with this process. So we're going to go to our y equals, turn it on, and then go to y equals. Rather, let's push this out of the way. And I'm going to type in our function here. It's alpha y equals to get the stacked fraction. And I've got x minus 4 over x squared plus x minus 6. If I graph that, so you have this curve down on the left, I have a U shape in the middle, and then I have that curve up on the right. So I know, for instance, where's my pen at? Okay, there we go. I know I have a U shape here in the middle. Between those, we've got this lower section. Again, we follow the asymptotes without touching them. And over here, because we found an x-intercept, we are going to cross and then follow from above. We aren't going to follow underneath that asymptote. The only reason I know that happens is because I found that place where it crosses the x-axis. That's what we're being expected to do. The next one, we're going to simplify this. We want to multiply and divide. The way we're going to do it, though, is by factoring first. So my goal here is to factor the top, x squared plus x minus 6. That's what we just had. So it should be x plus 3, x minus 2 over x squared minus 4. That's a difference of squares. So that's one of the easy ones. X plus 2, x minus 2. Over here on the right, we've got x and x. How do we split a 4 so that it adds up to 4? That would be 2 and 2. And because they're both positive signs, these are both positive signs here as well. And then on the bottom, again, x and x. How do we split an 8 so the numbers add up to 6? That would be 4 and 2. And because everything's positive there, the signs should all be positives. Alright, so I'm looking for things on top that are also on bottom. An x minus 2 for an x minus 2, an x plus 2 for an x plus 2, and an x plus 2 for an x plus 2. Leaves me with x plus 3 over x plus 4. Alright, in our next section we're going to solve using the butterfly method or cross multiplication. 3 needs to multiply by x minus 1. Make sure you distribute to get 3x minus 3 equals 4 needs to distribute, making 4x plus 4. To get all my x's together, I'm going to minus a 3x from both sides. Gives me negative 3 equals x plus 4, which if I minus 4, x now equals negative 7. The only thing you have to be careful about is making sure that it doesn't make the denominator equal to 0. That's our no-no. Since negative 7 wouldn't make either denominator 0, we are fine. Okay, the next section, our next piece, we're going to be working with this 3-piece fraction problem. And I'm going to think of the x minus 2 in a parentheses, the x minus 2 in a parentheses. And this x, even though it doesn't have any added or subtracted, it's its own thing. I'm going to use my least common denominator to clean this up. The least common denominator would be x and x minus 2. If I multiply each fraction by x and x minus 2, x and x minus 2, x and x minus 2, the x minus 2's cancel, or the x cancels, and we end up with x times x, which is x squared, 4 times x minus 2, which is 4x minus 8, and over here 2 times x is 2x. Because we have an x squared, we want to make this thing equal to 0, and so the way we're going to do that is by minusing our 2x over to the other side and getting x squared plus 2x minus 8 equals 0. Now if we factor that, x and x, how do we split an 8 so that when we minus we get 2? It would be 4 and 2. Because the 8's negative, I'm going to have different signs. Because the 2 is positive, I need a big positive and a small negative. That tells me my two answers are negative 4 and positive 2. But when we go back and look, a positive 2 would make x minus 2 0. So I have to reject that answer and only keep the negative 4. All right, we're on to trigonometry. We have this right triangle, and we need to find all 6 trig ratios. To do that, I'm going to need the third side. Pythagorean's theorem says a squared plus b squared equals c squared. A and b are any sides that aren't the hypotenuse. Since I don't know the hypotenuse, I can go 3 squared plus 4 squared equals c squared. Plug that in the calculator. It's going to be 25 equals c squared, and we square root. So c equals 5. So there's my missing side. Then I need to come from this angle and say that the 4 is my opposite side. Obviously the c is the hypotenuse. That makes the 3 the adjacent side. Sine is defined as opposite over hypotenuse. That would be 4 over 5. And cosecant is its reciprocal, 5 over 4. Cosine is adjacent, 3 over hypotenuse, 5. These are all fractions here, which would make this 5 over 3. And then tangent is opposite over adjacent. That would be 4 over 3. And cotangent would be the reciprocal, 3 over 4. When converting radians to degrees, we have 7 pi over 8, sorry. We multiply by 180 over pi, and the pi's should cancel. I then just have to put 7 over 8 times 180 in the calculator. So 7 divided by 8 times 180. That's going to give me 157.5 degrees. Okay. All right. Using to find these answers without using decimals, we're going to need access to a unit circle. So I'm going to flip over to my notes for chapter 13. If I can get this to go there. There we go. I come to chapter 13. We've got a right triangle here. You should have your tangents written down along the edges, but the off chance you don't, the tangent is 7 pi over 6. Let me go back here. 7 pi over 6 would be right down here. right? So I'm working off of this. That tangent is going to be connected to this rectangle here. Okay? And if we look at what you should have written down over here for your tangent, you should have root 3 over 3. And because I've got a negative negative in this 7 pi over 6 corner, my answer should be positive root 3 over 3. The cosine of 7 pi over 4 is the x-coordinate, if we can remember. So when I go back to the unit circle, I'll find 7 pi over 4, which is right here. I'm looking for the x-coordinate, which is a positive root 2 over 2. So I know that this answer is root 2 over 2. Sine of theta equaling negative root 3 over 2, this is telling me to do it backwards. I'm looking for the location where this is the y-coordinate. Okay? So if I go to my circle looking for y-coordinates of negative root 3 over 2, let's change colors here. The y-coordinate is the second coordinate. Negative root 3 over 2 occurs right here and right here. That would be at 240 and 300 degrees. So I'm gonna go ahead and say that my answer for degrees would be 240 or 300 degrees, and the pi equivalent to those would be 4 pi over 3 or 5 pi over 3. All right, so we're about halfway done. We're now going to use law of sines or law of cosines to solve this triangle, which is not a right triangle. I start by kind of listing off what I know. I don't know capital A. Capital B is 42 degrees. I don't know capital C. Little a is across from big A. That's 19. And little c is across from big C. That's 12. Don't know little b. Because I don't have a complete set, it means we're going to use the law of cosines. Because I know capital B, I'll use the B version of the law of cosines, which is b squared equals a squared plus c squared minus 2ac cosine of big B. So little b squared will equal 19 squared plus 12 squared minus 2 times 19 times 12 times cosine of 42. And to get b alone, I'm going to have to square root whatever number comes from all of that. So let's grab our calculator and see if we can get that calculation put in. We'll start with 19 squared plus 12 squared minus 2 times 19 times 12 cosine of 42. You do want to make sure that your mode is degree mode, which mine is. And so when I press enter, I get 166.13. And I need to take the square root of that to get my actual b value. So I'll take the square root of that answer. You get 12.89. Now that I know that that's 12.89, I can do this law of sines to finish finding A or C. Remember, the law of sines does not give me obtuse angles, so I want to avoid the big angle, and since little a is the biggest, I want to avoid finding big A. That'll be the thing I subtract from 180. So if I do the BC information over here, okay, so we're going to set this law of sines up with the sine of capital C over 12 equals the sine of capital B, 42, over 12.89. In order to solve this, we're going to have to times by 12 to clear this side. Times the whole thing by 12. Let's put that in the calculator and see where it takes us. So sine of 42 divided by 12.89 times 12 gives me 0.623. So the sine of capital C is 0.623 If I'll take a sine inverse of that, it should give me my final answer for C. So second sine of the answer is 38.5 degrees. Come out and say it's 38.5 degrees. And now with two angles, I should be able to subtract from 180 to find the third. So 180 minus 42 minus 38.5 is 99.5. So 98.5 degrees. And there's my final answer. Okay, we've got just a couple more trig problems. We've got to do some graphing. So remember that sine and cosine have a period of 2 pi over b. B is the number in front of x, which is 4 in this case, and this reduces. 2 over 4 is the same as a half, so this would be pi over 2. So when I go out 4 marks, 1, 2, 3, 4, I'm going to label that fourth mark pi over 2. Same thing to the left, 1, 2, 3, 4, negative pi over 2. Well, what's half of a half would be a fourth, so this would be pi over 4. What's half of a fourth would be pi over 8. And we get 3 of those to make 3 pi over 8. Okay, the next thing that we need to find is the amplitude of the wave. And the amplitude is always the number that sits in front of the trig function. This is a -1. The amplitude is the height, which is the absolute value of that number, so it'd be 1. So I'm going to go up to as high as 1 and down to as low as -1. I now just need to plot the points. Now cosine traditionally starts up at its high point right here. That's the knowledge, that's a memorized pattern. It starts up here, but because it is a negative, it's upside down. So we're going to plot that point here to center, opposite amplitude, center, and back where we started. So we get this style of shape. Okay, this is my cosine shape. I need to copy that as I go backwards in reverse. So we end up with something that looks kind of like an M. Whoops, Mr. Welch, let's do better. Should end up with something that looks like that. Sine, remember, would have started at the center right there if it was a sine, and move up and down from there. The tangent version looks different and behaves a little different. Its period is pi over b. In this case, the b is pi. Well, pi divided by pi is 1. So the fourth mark out, 1, 2, 3, 4, is going to be 1. And on the left, we'll call it -1. I do want you to label the halfway mark, and if that's 1, half of that would be 1/2 and -1/2. The next thing we need to do is insert the asymptotes. A tangent has boundary lines or vertical asymptotes at the second mark. Okay, and then also acknowledging that this is going to repeat every 4 marks, so I want to go out 2 additional marks to get to my next asymptotes here and here. Okay, let's grab a different color. And tangents, they like to cross right there in the middle of each one of these each time. And tangents typically go up as they go to the right. If it had been negative, it would go down as it goes to the right. But we're going to end up with something that looks like that, that, and that. Okay, that nice repetition. Okay. Okay, we are really close to being done. We're now at the point where we have to have the trig identities. We have to know what these things are equal to. You should have all this stuff written down. I don't see anything Pythagorean in this. There's no squares or addition, so I'm just going to turn everybody into my favorite 2 kids. So cosecant is the same thing as 1 over sine. That's over secant, which is the same as 1 over cosine. Well, when I have a stacked fraction like this, we like to keep switch and flip. So we'll keep the top as 1 over sine. We'll switch to multiplication, but then we have to flip this other one to be cosine over 1. When I multiply straight across, nothing's going to cancel, so I should end up with cosine over sine. And cosine over sine is, by definition, in your formula sheet, or in your identities, it should be the same thing as the cotangent of x. And that would be my final answer. Up here, I see this Pythagorean nature because there's squared stuff and addition or subtraction. That really sets me off, telling me that's what I'm looking for. The challenge here is that there's still multiplication going on back here. I need to simplify the multiplication before I can work the Pythagorean. So this is still going to have that CSC squared, the cosecant squared, minus, but I need to figure out what this thing is. It's the cosine squared of x times, instead of cosecant, I'm going to do 1 over the sine squared of x. Everything that was squared gets replaced with squareds. So I now have cosecant squared minus, and if I multiply straight across, I'm going to get cosine squared over sine squared. But I know that this thing right here, from what I did earlier, is the same as cotangent, but because they're squared, it'll be cotangent squared. At this stage, we kind of need to think about our Pythagorean identities. One of those says 1 plus cotangent squared equals cosecant squared. You should have that written down on your identity sheet. Well, if I were to move this cotangent to the other side, I would do it by subtracting cotangent squared from each side, so that 1 would equal cosecant squared minus cotangent squared. Since this is exactly what I have must be equal to 1. And there's my final answer for that. Okay, we've now just got a couple of final problems. We're solving this linear system by any method. We could graph them if we get y equals. We can do elimination. We can do substitution. I see this as a good opportunity to do elimination. And then what I look for is trying to make the x's match or the y's match but have opposite signs. Well, if I multiply this y by 2, it's going to become a positive 4y, which would cancel the negative 4y. So that's what I want to do. I want to multiply this whole equation by 2 and produce a new equation. That would be 14x plus 4y equals 26. And if I don't multiply this one, I get negative 14x minus 4y equals 26. When I add the stuff the way it is, this is what I was looking for, trying to cancel those y's. But as a byproduct, just coincidentally, these x's also cancel. Since everything on the left canceled, I have 0. And on the right, does 26 cancel 26? The answer is no. They would cancel if they had opposite signs, but since they have the same sign, it'll be 52. Does 0 equal 52? The answer is no. Therefore, we have no solution. Okay, last thing we're going to do is find the mean, median, mode, range, and standard deviation for the data. The first thing I'm going to want to do is put all of this data into my graphing calculator. So I'm going to go Stat and Edit. I want to clear my L1 if it's not already cleared. And now I've got to type all these numbers in. So we'll start with 24, 27, 28, 24, 29, 24, 23, 62, 22, 72, 82, 91, 29, 34. Now that I've done that, I can press Stat again, slide over to Calc, and run one variable statistics. On L1, I calculate, some information comes up. For instance, the mean is that top line, 40.79. So let's start with that. X bar is 40.79. I also need to find the median and the mode. Then those are all things that look for the center, and then the range, and then the standard deviation. So if I look back at my calculator, I notice the standard deviation is 23.66. So I can write that piece of information down. Where am I? Okay, there we go. 23.66. Also, if I go down, my median is 28.5. 28.5. The range is my max minus my min. That would be 91 minus 22. 91 minus 22. 69 would be my range. 69. And the last thing is the most common result. I noticed the 24 was there a few times while I was typing it in. I'm just looking to see if anybody else showed up more often. I don't see it. So I'm going to go ahead and say 24 is my mode. All right. Hopefully that helps you as you prep for your final. Good luck. We'll see you in class.